guys, how are you? Today we're gonna talk about binomial random variable. It's a very important type of stuff. Let's go for an example. We will gonna prove it off here. So let's say a biased coin has probability p for it. Let's say there is a coin which is having probability p, smaller p for having heads on it. Like we have only two probabilities every time. One of them is like head or tail in a coin. Actually there are only two probabilities, like if there will be head or there will be tail. So let's say its probability for the heads is small p. We flip it n times. Let's say we're gonna flip it up n times, many times. Let x be the number of heads obtained. We're gonna say that x, like the capital X, is denoted by heads obtained in this n times variable, or n times we're gonna flip it up. X is called a binomial random variable with parameters n and p. We're gonna say x is actually a binomial random variable here. Why? X is actually what? X is the number of heads obtained. We want to find that off here with the parameters. What are the parameters here? Parameters are n and p. N are the times we're gonna flip it off, and p is actually the head we're gonna obtain. So you must remember two terms here, which x is the capital X is the number of head obtained, and n is for number of times, and p is for what? P is for obtained heads, probability for head only. P is small p is for probability for head obtained, and in number of time we're going to flip it off, and we're going to talk about here x, which is binomial random variable, okay, for obtaining heads. So you need to know three terms here. Let's go for an example. We're going to flip it off for, like, we're going to say there are three tosses, like there are three coins. We're gonna flip them off three times. So already we know that when we will go for three coins, actually we're gonna flip them off. So the probabilities will be 8, because probabilities are 2 raised to power number of times. So number of times here is n, which is 3 tosses. And why are we going to choose 2 here? 2 is because there are only 2 probabilities, head or tails, in a coin. And we're going to toss them off 3 coins, like 3 tosses are there. So that are 3 tosses. And every coin has head or tail, so 2 raised to power 3 are 8. From the 8 sample space, from the 8 events, from those 8 events that are done, there are 3 of the terms in which 2 heads are obtained, like head, 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 head. Let's say this is the stuff out there, like only 3 out of 8 are them which are having 2 heads. So n are number of times we're going to toss them off. X is 2 heads, like how many heads? 2 heads, we're going to find them. Let's say p is small p is denoted by h, and t is equal to 1 minus p. Let's say heads, every time there is head, we're gonna say it's like p, and 1 minus p, which will be p squared 1 minus p. Same for here, p 1 minus p squared 1 minus p, 1 minus p. So we're gonna add them off. They will be 3p squared 1 minus p. Okay, that's how we do now. Okay, so let's talk about more here. Let's say now we're gonna go for x is equal to 0. Like x is equal to 0 means there will be 0 heads. If there will be 0 heads there, so there means there will be 3 tails, which are 1 minus p cube. Let's say there is 1 head only. So probability of them is 3p 1 minus p squared. Let's say there are only 3 heads, there may p cube. So all of them, when we're going to add 1 minus p cube plus 3p 1 minus p squared plus p cube plus 3p squared 1 minus p1, all of the stuffs are going to be, all sample space is going to be equal to 1 out there. That's known as what? That's known as P of S is equal to 1 actually. Let's say now we're going to talk about it. Let's say now we're going to generalize the thing here, but we're going to first doing for k is equal to 0 up till 3. Let's say we're going to perform 0, 1, 2, like 3 units are there from 0 to 3. And probability is equal to x is equal to k is equal to 1. Okay. Now generalize p of x, k is equal to p, x is equal to k. Now what's k here? Like what we're gonna say here is x is equal to k. Let's say the x was like anything. Like we just went for the example like number of heads out there. You say is equal to k. Then p x k is equal to p x is equal to k. Like we're gonna generalize the things out for so many things here. So now let's say p x k is equal to n k p k 1 minus p n minus k. Let's say heads is for p and tails is for 1 minus p off there. So when we're gonna offer 0 to n, like we're gonna perform infinite type of stuff there. Then the things will be p x k, as we know, which will be equal to same stuff here, right hand side, nk pk 1 minus p n minus k, 1 minus p n minus k is equal to p plus 1 minus p per n is equal to 1. Like p plus 1 minus p per n, p will be cancelled with p, 1 power n, any power 1 is equal to 1. Okay, so that's how we do. And the units are not in like one like negatives. So that's how you prove the things off here. That's how you do this. That was all about binomial random variable and binomial distribution. Thank you. We're going to talk about k here. Like if you're not gonna be there for k, you have not been with k. If I had not explained it correctly, so k is actually the success rate. We're gonna say p as we denoted for head. We say p for the success of head. There is k, like head per k. How much success rate is there? We're gonna talk about that. Like n is number of flaps and k we're gonna have success. Like if there will be head or not. How much success rate is that there? That's a formula for it. P means heads, then success rate. 1 minus P means tails, then K means success rate. Like you know what success rate means? Yeah. That's how you do K here. Okay. So that's what K is.